students. Our today's topic is Runge Kutta method of fourth order. In the previous video, we have learned about Runge Kutta method of second order. It was easy method. Now this is the iterative method, and what this method gives us, this method will give us higher accuracy without performing more calculations. It gives us more accurate values. Again, the method provides the approximate value of y for a given point x or for a given value of x. Again, only the first order ordinary differential equations can be solved using the Runge Kutta fourth order method. That means all these methods are used to solve the ordinary differential equations of only first order. Now, the most commonly used fourth order Runge Kutta formula is given by. Now, this formula is y1 is equal to y0 plus 1 by 6 into k1 plus 2k2 plus 2k3 plus k4. Now, what are this k1, k2, k3 and k4? Here k1 is calculated by using this formula h into f of x0 y0. K2 is h into f of x0 plus h by 2, comma y0 plus k1 upon 2. K3 is h into f of x0 plus h by 2, comma y0 plus k2 by 2. And k4 is h into f of x0 plus h, comma y0 plus k3. So this is the formula for Runge Kutta method of fourth order. And these are the values of k1, k2, k3 and k4 we have to calculate while solving the example. So let us take one example. Using Runge Kutta method of fourth order, solve dy by dx is equal to 1 plus xy. Here the function is 1 plus xy and y of 0 is 2. That means here x0 is 0 and y0 is 2. And we have to find the value of y at x is equal to 0.1 using the fourth order method. So let us see the solution of the given problem. Here, as we have given the function f of x comma y is equal to 1 plus xy and x0 is 0, y0 is 2 and h is 0.1. So by Runge Kutta method of fourth order, here we have this formula. And we can calculate the values of k1, k2, k3 and k4 for their corresponding formulas. So here k1 is calculated by h into f of x0, y0. Now our function is 1 plus xy. So here f of x0, y0 will be 1 plus x0 into y0. 1 plus x0 into y0. Now x0 is 0 and y0 is 2. So this value will become 0. So h into 1 plus x0, y0. So this value becomes 0. So 0.1, h is 0.1 into 1 plus product of x0, y0 is 0. So here we get k1 is equal to 0.1. K1 is 0.1. Now to calculate k2. The formula to calculate k2 is h into f of x0 plus h by 2, comma y0 plus k1 by 2. So here x0 is 0, h by 2 that is 0.1 upon 2, y0 is 2 and k1 we get 0.1 divided by 2. H is 0.1. So putting all the values, here we get 0.1 into this 0.1 divided by 2. So f of 0 plus 0.1 upon 2 that is 0.05 and 2 plus 0.1 upon 2 that is 2.05. Now as our function is 1 plus product of xy. So here we get 1 and this is, suppose this is x and this is y. So here the product is 0.05 into 2.05. And after calculating, we get k2 is equal to 0.1103. Similarly, we can calculate k3 equal to h into f of x0 plus h by 2, comma y0 plus k2 by Now our K2 is 0.1103. H is 0.1 and x0 plus h by 2. x0 is 0, h by 2 is 0.05 and y0 is 2 and K2 by 2, that is 0.1103 divided by 2. This value is 0.05 and this value is 2.055 and 2. So as our function is 1 plus xy. So this is x and this is y. So after calculating, we get K3 is equal to 0.1103. Now K4. K4 is calculated using this formula, h into f of x0 plus h, comma y0 plus K3. So K3 we have calculated. So h into f of x0 is 0, h is 0.1, y0 is 2 and K3 is 0.1103. That means this is x, this is x and this is y. So as our function is 1 plus x into y. So our x is 0.1 and y is 2.1103. So h is 0.1 and using the function we get 1 plus 0.1 into 2.1103 and finally calculating we get K4 is equal to 0.1211. So all the values of K1, K2, K3 and K4 we got and we will put them in the original formula, that is y1 is equal to 2 plus 1 by 6 into 0.1 plus 0.2206 plus 0.2206 and plus 0.1211. So after calculating, we get y1 is equal to 2.1104. That means we got the value of y1, that is y of 0.1 equal to 2.1104. So in this way, using Runge Kutta method of fourth order, we can solve the ordinary differential equations of first order. And solving such examples, you can solve more examples for Runge Kutta method of fourth order. Thank you.